Thank you so much, sir, for enriching this technical seminar with your new technology. Now we have with us Sri Bhushan Nahire and Sri Pankaj Mohabey from TPF Engineering. Bhushan Nahire is a General Manager in Design Department at TPF Engineering, Mumbai. 13 years of professional experience in design consultancy. He has worked in various iconic projects of India like Atul Setu Cable Stayed Bridge in Mandovi River, Cable Stayed Bridge over River Juari, Elevated Corridor at Nasik, Mumbai Trans Harbour Link Project, Elevated Corridor at Ravindra Bhavan Junction, Hybrid Cable Stayed Bridge over River Krishna, Telangana. So such a vast experience. Bhushan Nahire, please come on the stage and big, huge round of applause for him. And we have Pankaj Mohabey also. He is Associate Vice President of TPF Engineering Private Limited. He is having 33 years of professional experience, 28 years in construction and 5 years of consultancy. Mr. Pankaj has also worked on the prestigious projects like Eastern Freeway Mumbai as project manager and Nasik Pipalgaon Gonde Highway, Maharashtra as a team leader. 455 MLD WTP for Mumbai as project manager, 765 kV transmission lines as senior project manager, etc. So we have two eminent speakers, and this topic is innovative bridges, sustainable technology in bridges. So first, I would like to invite Sri Bhushan Nahire on the stage to start, and after that, Sri Pankaj Mohabey. So again, Jordar Taliyan.
Thank you, sir. Good afternoon, everyone. Myself, Bhushan. I have been working as a design engineer for the TPF Engineering from last 13 years. We were discussing in the first session about innovations. So as sir correctly pointed out, innovation is something, is the soul of a design engineer. So we at a TPF Engineering had decided to innovate 3 to 4, I have brought 3 to 4 case studies here about the innovative bridges that has been recently constructed in India. So, what is actually innovation means? Or what are the parameters that are considered innovation? So the first part is strength and reliability. The second part is stunning designs, as our chief guest earlier mentioned about the beautification or designs of a bridge, which was maybe last decade was not considered as a major thing in India, but nowadays we are looking at a beautiful designs. And then the reduced congestion. So as a design engineer or an innovator, what we think about a bridge? So we conceptualize the bridge first, then we do analysis and modeling, and then we think about the construction methodologies of how to go about this project. So as I said, conceptualization considers creating a vision of a bridge, considering functionality, location, and aesthetic, which is a more an important part in it. Analysis and modeling is something that a basic design engineer will start with FEA model. So we will do the analysis and modeling part of it, and how the construction friendly the design can be. That is the more important thing for a design engineer. So I will presenting 3 case studies successfully completed in India. The one is Cable Stayed Railway Overbridge in Goa. The second is Zuari River Bridge. And the last is something which is never happened in India, and then we are the ones who are going to bring back this technology in India. So when I say innovative bridge, this location, actually the client came to us with a problem of having a live running track below, and there is a first level corridor. They wanted to connect the southern part of Goa to the northern part of Goa with a ramp. So we came up with this innovative proposal of connecting that with a cable stayed bridge, because generally if a design engineer someone is here, he will understand that the designing a bridge on a curvature is very difficult part. So we took up this challenge, and we innovated the bridge in such a way that the bridge was constructed on a radius of 180 meters. The major features are that the structural steel quantity was about 2,000 tons. From the aesthetic point of view or innovation part of view, we tried to provide a namaste shape to the pylon, which is kind of a pier for everybody's understanding. This is how the deck of the bridge was designed. Anchors are the most important parts of a cable stayed bridge, where the cables are transferring the load from the anchor to the substructure, superstructure, and then the substructure. So this is how the location is now. So when I said the lower at the last, at the ground level, you can see railway track. Over it, you can see a already constructed bridge, and on top of it, we have constructed this cable stayed bridge. So this was the first case study that I wanted to discuss with you. The second case study is Zuari Cable Stayed Bridge at Goa. Now, this is the widest bridge in the world, and in India, which is a 54-meter wider bridge, which was inaugurated last year by our Honorable Minister, Mr. Gadkari. So again, this is 4+4 lane cable stayed bridge with, if you see that two pylons, two piers, the distance between the two pylons is about 360 meters. And the total length of this bridge is about 640 meters. So the structural steel quantity was about 22,000 tons, and the stay cable quantity was about 1,500 tons. The construction methodology, for a design engineer, the construction stage forces are very important. So due consideration was given to the technical parameters such as deflection, the structural steel weight, and the panels. So the unique feature is that we were actually consultant on this project, but during the construction of project, COVID happened, and the design consultant who was actually supposed to design this bridge was from Europe. He could not come back to India for completing the design part. So Ministry of Road and Transport expected us to complete this bridge with the remaining design. So they had this construction sequence of connecting lifting a segment, which requires 18 days of time. With our innovation, we could reduce this to 10 days. That helped the completion of the project from 18 months to 12 months. So due to, because of the this reduced construction period, the project got completed in 12 months. So these are some of the pictures that how the bridge was constructed. I just wanted to run through the video of how the bridge looks like. This is the river Zuari, where the southern and northern part of the Goa is connected. You see that those pylons, that the columns are of height of 110 meters, which is about 35 story building, just to get an idea. On this bridge, from tourism point of view, we have constructed a tower. The construction is going on site right now. So
Reduce volume, please. Volume of video.
Yeah. So for this, from tourism point of view, we have constructed a towers on this cable stayed bridge so that people can have a beautiful view of the sea. So this is first time that we have conceptualized this in 2017-18. So this is something like innovation for any cable stayed bridge designer, so that, during the construction you can have the viewing galleries also. So, I mean, this is how the big bridge looks like right now. Yes. This is the bridge that everyone in Delhi actually is talking about in the Ministry of Highway and Road Transport. This is the bridge which is neither a cable stay nor a suspension bridge. We wanted to push our limits because in India we have a cable stayed span of up to 360 meters, which I showed you earlier. Now with this bridge, we have gone up to 480 meters now. So the distance between two piers is 480 meters, which is something was never done in India before. So with this bridge, we had done a cable stay arrangement with a suspension cable. So it is called a hybrid connection of stay cables with suspension cables. The unique feature of this bridge is that you have two levels of service on this. On the deck level, you have a vehicular traffic, and at the second level, you have a walkway, which is a glass flooring. So this is how the general arrangement of the bridge is. This is how the bridge will look like. When we are in the construction phase now. A lot of detailing was done to simulate the local understanding of the people. So we wanted to give the shape, to innovate that a pylon to a Gopuram shape, which is kind of a temple in South India. We have a viewing gallery below the deck now. So the technical parameters are, we have a semi-fan type of arrangement. This is RCC pylon with Gopuram shape, steel composite bridge. We have a truss type of superstructure. This is how the pylon will look like. So this is what I was talking about, that we have a deck level at the first level. So if somebody can understand, this is something which vehicle traffic will run through, and then right below it we have a glass walkway, and then there are the people who can walk on the sides. If somebody wants to enjoy the adventure, they can use that 6-meter glass walkway also. So this is how we wanted to have crossovers, so we have provided crossovers at every 60-meter interval. Suspension cables, technical part. These are the saddles where the cables run through. This is the mathematical model that we had prepared for the suspension cable bridge. Unique features of the bridge is we had compared this costing of the bridge to the earlier highest cable stayed bridge, and we found that there was reduction in the stay cable quantity. Then the improved stability in the wind, for the wind considerations. Height of the pylon was reduced because if you go with 480 meter span, the height of the pylon could have been 200 to 250 meters. Because of this arrangement, we could reduce that to 175 meters. So this is how the animated look of the bridge is, that we have a glass walkway at every 3 meter, alternate side, a 3 meter and then a 6 meter glass walkway. We have a small video of it also. इसमें आवाज
Sprawling and serene Krishna River forms the border between the two states of Telangana and Andhra Pradesh. New National Highway NH 167K between Kalvakurti to Nandiala crosses the river Krishna near Somasila, famous for Sri Lalita Someshwara Swami Temple on Telangana side and near Sangameshwaram Temple on Andhra Pradesh side, through the proposed iconic bridge. The bridge is located in a picturesque landscape with sprawling Sri Sailam Reservoir surrounded by Nalamala forests and hills. This proposed iconic bridge would be the gateway for both the states and will help promote tourism besides improving connectivity. With this bridge, the connectivity gets completed, reducing the distance between Hyderabad in Telangana and places like Nandiala, Tirupati, Chennai, etc. by a whopping 80 kilometers. When seen from Somasila, the bridge presents an iconic view, which is unique in its aesthetics. Appropriate junctions and lane reductions are designed to allow entry and egress from NH to Somasila Temple. On Andhra Pradesh side, also appropriate junctions and lane reductions are created to allow entry and egress from NH to Sangameshwaram temple. The proposed iconic Krishna River Bridge is technologically unique with use of hybrid suspension cum cable stayed structural arrangement. Clear span of 480 meters between supports and balancing spans of 192 meters on either side. With clear navigational height of 30 meters, the bridge blends beautifully with the scenic surroundings. The four-lane bridge welcomes you through the pylons, inspired by gopurams of South Indian temple architecture. The pylon rises up in a series of receding stories like the talas of gopurams. The top section also exhibits design resembling the gopurams of the South Indian temples. The Kirti Mukha's inspired silhouette on two edges and one in center of the barrel in elevation displays the state emblem. Travel on the bridge across Krishna River in the midst of a scenic landscape creates a beautiful and long-lasting experience. Along the sides of the road, a ramp leads down to the pedestrian walkway below the vehicular deck. The box section of the road bridge is made into a series of arch trusses. The pedestrian walkway is 2 by 3.45 meters with series of benches for sitting along the length of the bridge. Full height protective rails on the edge allow pedestrians to enjoy the scenic river and landscape along with the view of temples. The space between the two pathways is a walkway with glass decking. This is the longest pedestrian glass bridge across a river in the world. This glass bridge provides the view of the Krishna River below. This glass bridge will attract tourists from all over as it is going to be an experience of its kind in the world. The entrance and exit points of this pedestrian bridge are also designed as gateways. The entire pedestrian bridge along with the entry ramps are physically challenge friendly, allowing wheelchair, electric cart movement between two ends. When seen from Sangameshwaram temple, this bridge gives a closer look of the bridge form. The whole bridge is illuminated with special facade lighting to give travelers, tourists and pilgrims a unique experience at night. These combination of gopurams like pylons and hybrid suspension cum cable stayed structural arrangement, the glass pedestrian bridge all put together makes this bridge an iconic bridge, never done anywhere before.
So with this bridge, if you see that we have connected the two state boundaries actually with the Telangana state and the Andhra state. Now, just I would like to brief you about the project which is going to be opening shortly in Mumbai, which is the longest river bridge in the India, which is about 21.6 kilometers, a sea link. This is how the bridge looks like, which is in Mumbai actually. Then we had completed this Mandvi cable stayed bridge in year 2019. MG Setu in Patna, we were the consultants for this project, which is again an iconic structure with 120 meters trusses. The longest bridge in India till now is Bhupendra Hazarika Bridge. We were again the consultants for this bridge, and this was one of the iconic structures of India. Now I can we'll discuss about the future possibilities of innovation. So we think about the smart infrastructure. Smart infrastructure means that we need to have sensors who can predict the behavior of the structures during the function life of the structure. Sustainability, the bridges should adopt to eco-friendly measures like solar panels, energies, technologies to reduce the carbon footprints. Use of artificial intelligence is more important these days now, wherein we can, with the help of AI, to provide real-time feedback to the people or the commuters on the traffic and weather conditions. Challenges with the current technologies we as a design engineer feel is environmental impact, the cost and the maintenance of these innovative bridges. The later part of this session will be handed over by Mr. Pankaj now, who is going to discuss about the sustainability in bridges. Thank you.
Thank you, Mr. Bhushan Nahire. Now the same topic, second part will be taken over by Sri Pankaj Mohabey. He is Associate Vice President at TPF Engineering Private Limited. He is having 33 years of professional experience, 28 years in construction and 5 years of consultancy. Mr. Pankaj has also worked on the prestigious projects like Eastern Freeway Mumbai as project manager, Nasik, and Nasik Pipalgaon Gonda Highway, Maharashtra as a team leader, 455 MLD WTP for Mumbai as project manager, 765 kV transmission line as senior project manager. So please welcome him with a big hand on the stage. Pankaj Mohabey, the same topic is continuing. The sustainability part will be dealt by him.
Thank you, sir. Thank you, Bhushan. Good afternoon, everybody. Yeah. Today I am giving the presentation on sustainable bridge technologies. The sustainable bridge technologies consist of the sustainable materials, renewable energy, smart sensors, and the 3D printing. The sustainable materials, the new materials are being developed that withstand the heavy loads while being more environmental friendly. The renewable energy, just like a solar energy, which will be useful for the, you can say, lighting and all. The smart sensors, the modern sensors are also being incorporated in the recent times now to detect the damages in the bridges, right, real-time damage in the bridges, and this also reduces the, you can say, frequent inspection of the bridges, because you are having the one cabin and you can just monitor from there, and you need not to go and do all the, you say, MBIU and check the bridges. The 3D printing technology can create custom-made sustainable bridge components that are significantly stronger than the conventional bridges. The need for the sustainable materials. You can see the deterioration of the conventional bridges. So for that we need this, you can say, the technology of the technology of the, you can say, of sensors. You can bring it in the sensors and you can see, you can check it here, and you need not to wait for such a long time to get deteriorate and then go and inspect the bridges. The various deteriorations have been seen here. In sustainable materials, actually I am just concentrating on the hybrid composite beams. In this, the hybrid composite beams, actually I will take you the part of the technicality and its construction and its benefits, like in the transportation or what. The engineering theory behind the HCB is that the tension is we are using the arch analogy, It's a very unique technique. Actually, it is not brought in India, just we are, as a TPF, we are bringing this. Tension use arch analogy for the reinforced concrete to eliminate all the concrete to the tension. Compression, the resistor compression thrust of the arch with the steel tie. And the shear is carried in arch and in FRP webs. Now, what are the FRP webs and what are the compression thrust and you can say steel and this just I will show you in the next slides. The SCV spans can be span anywhere between 6 to 32 meter. It is a proven in the outside USA and all. And we are also trying it for the making it up to the 40 meter. When we, this can be, the SCV beams, actually there are the two types of them. We can place in the two, in the cast in situ or you can pre-filled or you can say precast. So when we can go with the precast, it's only a 1/10 of the conventional concrete beams. Means our regular concrete, it will be only a, if it is a 100 tons, it will be only a 10 tons, only the shell is there. And if you fill it with the concrete, then it will also become the 1/3 of the conventional girders. This is an inspection manual available for based on the 0 to 9 BBIS rating criteria of the. They require little or no maintenance, even extremely aggressive environments. Here you can see this fragmentary perspective of the HCB. The blue line is the blue color is being the shell. It's only a U shell is there, and you can see the yellow color which is in the foam. The foam is only supporting the arch, concrete arch, which is the compression reinforcement. And the yellow foam in our conventional bridges, actually conventional girders, we used to just provide the concrete in this, but here we are replacing it with the foam to make it the lightweight. And in the bottom, just we are putting the tension steel in the form of the strands. And after casting of this arch and all this, you can just put the lid on the top of the girder, and it will become it will give only a rectangular shape. And you can also cover it by the FRP. Now, what is the FRP? You can see here in detail. This the back one is the pointer chalta hai? This white one is the foam, and this the curved portion is the compression reinforcement, that is the curved. And FRP sheets are being shown. Actually, it's the FRP shell is there. And in that shell, the actual number of FRP laminates are actually we have to put it, and which will get binded with this resin. The FRP shell is consist of the actually fiberglass laminates. The laminates are also coming in the three types. One is the horizontal one, and this is the vertical and horizontal, and this is the cross one. But balanced coordinate fabric with the fibers that are horizontal, vertical, and this are more useful in this type of girders. These FRP sheets, what we used to do, these FRP sheets actually consist of 4 or 5 sheets are there. Actually, by tubing, actually we infuse the resin into that, and we can make it as a one. You can say one monolithic. You can say one shell. So after on the other side, you can see that the vacuum pump is there, and the left hand side you can see that the resin is coming. So we have to create the vacuum because it's of the thick viscosity. We have to create the vacuum, and we have to put it infused into the FRP sheets. Once it gets applied all over the corners, then the FRP sheet we have to leave it for the 4 or 5 hours. Then it will become a complete shell. The pictures are here. The 4 layers of glass fiber mat, which is being casted, and the right one is the, you can say, bottom of the reinforcement is showing that the strands are there. These are the strands which are being used as a tension reinforcement of 1860 MPa. This is a steel sheet used to fabricate the molds. That means actually just before infusing this, the beam as per design and drawing, actually this is the outer one, and we just put it, you can say, inside mold, and then we infuse the resin in this. This is the top lid after casting of this, the top lid is there, that we have to put the top lid. That is also we are infusing the resin into the fibers, laminates. These are the 4 stages. The polysofoam being placed inside. Second one is the beam as per the design that we have to, you can say, put the laminates and we have to make a shell. And the vacuum infusion process is done. And third one is the SCB girder ready for the dispatch. You can see here the comparison between the SCB girder and the conventional box PSC girder. Here, actually, here we have just, the girder, the segment is a single segment is there, which is very big in the tedious in the transportation, and very heavy machines are required to lift this conventional segments. In this we can use a small cranes also. Just I will show you the later on. The benefits of the SCB technology. It is lighter in the weight, reduce the carbon footprint, optimization of the every material use, sustainable, simplicity in the design, fabrication and erection, provide the public safer bridges, reduce the burden of the infrastructure of the future generations. You can see here the beams are so compact and very easy to load. You can see here the Farana crane, I think, is there, and the Farana and the Hydra crane can be used to just lift the girder and place it, because it's only a 1/10 of the weight of the conventional concrete girders. Here in segments, actually we are able to only transfer the one segment. Here we can transfer the 4 beams at a time. Again, the unloading is also very easy. With a small crane, we can unload it. This reduces the risk factor, because the heavy loading and the transportation is a very big problem and very risky, and we have seen that many accidents are happening. So it is very useful for reducing that. These are the photographs, the cast-in filling, you can say. Again, these are the casted diaphragm is shown. These are the exact views of the constructed bridge from the bottom. This is the load testing by the BNSF railway bridge. This is the already casted bridge, completed. Again, you see that it's a very small amount of the, you can say, efforts are required for this to just unload the, you can say, or place the girders. The benefits of sustainable bridge technologies. It's a cost saving. Sustainable bridge can be cheaper than the conventional constructed and the maintain over the long term, reducing overall cost. Environmental impact. By using the sustainable materials and renewable energy technologies, the sustainable bridges have a much smaller environmental footprint. Here, actually, because of the lesser transport, lesser cranes, lesser, you can say, lesser amount of the machineries are required. So that is there. Increased safety. Because since heavy loading is and unloading is not required and the heavy transportation is not required, so major launches are not required. So it's a very good for the safety, or you can say helpful for the safety, and improved aesthetics. So sustainable bridges can be designed to be a visual stunning, creating the landmarks, because it's only a laminates. We have to mold it and we have to place it and into resin. Conclusion. Bridge technology has come a long way since the early wooden planks and the pointy arches. Today now, at the state of the art engineering marvels than defy the gravity and expectations. As sustainable bridge technologies becomes, the more mainstream costs are likely to fall. Because in coming years, now this type of the SCB technology will come, and it will reduce the, you can say, weight, cost, material, and directly it will helpful for the environmental also, because natural ingredients may also require less as compared to our conventional girders or structures. Secondly, is that it reduces, just I said that it's only 1/3 of the weight of the conventional girders. So if you see that the dead load of these girders are less. So superstructures, the dead weight of the superstructure get less. So the substructures and even the foundations, that also get reduced. So in total, if you go that, it will be even more economical than our conventional bridges and easily maintainable also. Thank you very much.
Thank you, Bhushan, Nahire and Pankaj Mohabey. And there was a mesmerizing presentation of Kaveri hybrid bridge. That was मंत्रमुग्ध करने वाला परियोजना है वो. और अब मैं आप दोनों को बुलाऊंगा, आप आ जाएं मंच पे. और पहले भूषण नाहिरे जी आएँ और उसके पीछे पीछे आप आएँ. So now I would request the chairman of the technical session, Rajiv Lochan sir, to honor him, honor Bhushan Nahire from TIFF Engineering with shawl, bouquet and memento. So, जोरदार तालियां. पंकज मोहाबे जी आप आ जाएं. अब मैं को चेयरमैन वाहिद कमर फरीदी साहब जो मुख्य अभियंता हैं, चीफ इंजीनियर हैं नेशनल हाईवे के, उनसे निवेदन करूंगा कि पंकज मोहाबे जी को बुके, शॉल एंड मेमेंटो देके उन्हें सम्मानित करें इनके और स्टैंडिंग कंट्रीब्यूशन के लिए इस सेमिनार में. तालियों में कमी नहीं होनी चाहिए.